All right, we're talking functions and relations today. So a relation is basically any set of points that you can put on a graph. So like a finite set of points, where you just have a certain number of points, or an infinite set of points, like where you have, a line or a circle or a shape of any sort. Those are all going to be relations. Now, a function is a special type of a relation because a function makes one distinction, that for every x value there can only be one y value. So any number that you put in, it can only churn out one y value. Okay, and so because of this, it always passes the vertical line test. The vertical line test basically says that if you draw a vertical line anywhere in that graph, that it will only ever touch one point on the function at one time. So like a sideways parabola wouldn't work because you'd have a vertical line that would touch 2 points on the parabola. Okay, so then if we look at the domain and range, sometimes these are actually kind of challenging to see. And the first time you learned this, you might remember that it was actually kind of hard for you. But let's think about domain. Domain is the set of all the possible x's. So this is all of the x values that are legal for you to put into that function, okay? Because we got to follow math law, right? And math law is the best kind of law. So we have to follow the law of math. So there are things like, if you look at a graph, first of all, I guess, if you look at a graph, you can say, well, the farthest left that we go would be one part of the domain, and then the farthest right we go is the other bound of the domain. So basically, if you look at a graph, you say, okay, how far left and how far right, and well, everything in here in between is the domain. Okay, so that's a graph. But sometimes you'll just have an equation and you'll have to figure out what the domain of that is. Well, what you do is you figure out, are there any x's that when I put them in, they break the math laws? Okay, well, one of the math laws is you can't divide by 0. So is there any x that if I put it in there, it's going to give me a 0 in a denominator? If there is, then it can't be part of the domain. You can also ask yourself, are there any values that when I plug them in, they're going to give me the square root of a negative? Well, because we cannot take the square root of a negative and get real numbers, which is what we're working with, not imaginaries. So the domain would not include any numbers that would give you, the square root of a negative number. So that's how when you have an equation, you can see what the domain is. And then the range is all of the outputs. So the range is everything that can come out of that function. Okay, so when you say, all right, these are all the x values that I'm going to put in the function, and if I put those x values in, what am I going to come out with? And the range tells you that. Now, oftentimes you really have to look at a graph for the range. Sometimes you can just like picture the parent graph in your head, but that's usually the best way, is to look at a graph. Okay, so let's take a look at the first one. So the first one says x plus y equals 1. Well, that is a line. That's a line with slope -1, intercept of 1. So lines are always functions because, they don't double back on themselves or anything crazy like that. So this is a yes. This is a function. Okay, the second one is a circle. Now, if we look at the circle and we tried the vertical line test on this circle, we see that the vertical line test fails, in lots of points on this circle. But we look at that and say, okay, well, for every x, there's actually 2 y's. So that one is not a function. So we're going to say no. Okay, now this one right here, we need to know our parent functions to be able to make some determinations. Well, this parent function is a parabola, and so it looks like this, and we know that parabolas, when they're facing upward, are functions. So yes, this is a function, okay? And now if I look at this one, here's a problem right here because I have a y squared. And the y squared tells me this is a sideways parabola, you know, because our y's are the ones that are squared. Well, sideways parabolas do not pass the vertical line test. So this one is not a function. All right, let's see what we do when we just plug numbers into a function. Okay, f of 10 means that, you know, see how the x is in here and then there's a 10 here. So I just take the 10 and I put it everywhere that I see an x. Okay, so f of 10 would be 3 times 10 minus 1, which is 29. So f of 10 is 29. Well, what about g of x plus delta x? Okay, well, g of x is just x squared. So let's write that function. We have something squared, okay? And then what we're going to put in here, instead of this x, instead of x in here, we're going to put this quantity in there. Okay, so we just put that in, x plus delta x. And we could be done right here because we're in calculus, and in calculus we don't have to simplify. But just for kicks and giggles, you might realize that you could FOIL this and you'd have x squared plus 2x delta x plus delta x squared. But again, in calculus, I wouldn't go there because what if you FOIL wrong? So just leave it in that simplified version unless the problem asks for it to be explicitly simplified. Then you do want to simplify. Okay, now g of f of x, well, that means that we have g of x, which is something squared, and we're going to put f of x anywhere we see an x in g of x. So that's going to be f of x is 3x minus 1. So g of f of x is 3x minus 1 squared. And fog, or f of g of x, is just another notation for this same concept. This is going to be our parent, or our outside function, f of x, is 3x minus 1. Okay, but everywhere we see an x, we're going to put g of x, so that's going to be 3x squared minus 1. All right, let's look at domain and range for each of these functions. So again, if we have a graph, sometimes it's easier to see the domain and range, but sometimes when you don't have a graph, you just have to think about it realistically. Okay, so let's look at this one. If you look at this one, this is a square root. So there are numbers that this cannot take on, because if I put in 0 right here for x, I'm going to get 0 minus 1, which is negative 1. I can't take the square root of negative 1 and get a real number, so that's not part of the domain because I can't graph it, right? So I have to think, okay, what numbers, if I put them in here, are going to be illegal? Well, if I put 1 in there, I get 0, and the square root of 0 is perfectly legal, but anything smaller than that, I get a negative number, and I can't take the square root of a negative number. So my domain for this one is going to be everything bigger than 1, right? So I'm going to include 1 because I can have 1 all the way to infinity. Now my range for this one, to see the range, we really can graph it. That's usually the easiest way. Now remember, this is the top half of a sideways parabola, and because of this minus 1, we're moving over 1. And we know that because that's what our domain is. Oh, that's beautiful. Oh, look at that. That's so wonderful. Okay, so think about this top half of the sideways parabola and think, okay, what's our range? Well, it's because we know it's not shifted up or down at all, that it starts at 0 and goes to infinity. Okay, let's take a look at this next one. So for this one, again, we need to think of things that are illegal for us to do in math. Well, taking the square root of a negative is illegal, and dividing by 0 is illegal. So what is our domain? Well, there's a specific number we cannot put in for x because it would make this illegal. Well, that would be 2. We can't put 2 in there because then we get 1 over 0, and that doesn't work. So our domain is everything except 2. So, you know, you could say all reals, except x does not equal 2. Or you could say negative infinity to 2, and then 2 to infinity. Okay? Or you could say, yeah, actually that's probably the best one. I don't know that we would do any other inequality notation here. Okay, so the range, again, for the range we have to think about this graph. Well, this graph looks like this. But it's shifted over, so this is a horizontal or a vertical asymptote at 2, because again it can't equal 2, but it can get really darn close to 2. But it's got this vertical or horizontal. Yeah, did I say horizontal? Anyway, it was a vertical asymptote at 2, a horizontal asymptote at 0. Okay, so our range is negative infinity to 0 and 0 to infinity. So that's the only value it can't take on is 0. So we make sure, again, our brackets have to be open for that one. Otherwise, that would just be all reals. Okay, now let's look at this other graph and let's figure out some domain and range from here. Okay, so it looks like we have a vertical asymptote right here. And it looks like we have a vertical asymptote right here. So it looks like the two x values that do not have any place on this graph are at 0 and at 2. So our domain is all reals except x is not equal to 0 and x is not equal to 2. Okay? So those are the only two values of x that we cannot put into this function. And then our range, it looks like from negative infinity, way down here, all the way up to y equals 0, we have some points on our graph. You know, a lot of times I'll take like a ruler and I'll start like down here and I'll go like this and like, okay, at what point do I stop getting numbers on my graph? Well, when I get right up here to 0, now I have no numbers on my graph that equal 0. And then if I go, you know, even between 0 and 1, I don't have any numbers on my graph that have that as their y value. So I'm going to say my range is negative infinity to 0 and 1 to infinity. And in this case, we're actually going to close that bracket at 1 because if you look, there is a point at 1. So that one does count. All right, so let's talk about one-to-one functions and what they are. So basically a one-to-one function is one that passes the horizontal line test, or the vertical line test, and the horizontal line test. In other words, for every x, there's only one y, but then for every y, there's only one x. So none of the x's or y's are repeated at all. So think about a parabola. That would not be a one-to-one function because there are some y values that have two different x's. You know, x equals 2 and x equals negative 2 have the same y value, the same output. All right, so for inverse functions, basically what we do with inverse functions is we switch the x and the y, and then we solve for y again. So they have to be 1-to-1 to be able to be an inverse, because they're switched. The domain of f is the range of f inverse. So this is how we write f inverse. It's like an f with a little -1. Okay, so the domain of f is the range of f inverse, and the range of f is the domain of f inverse. And so basically you can just like switch all the points, you know, like when you have an equation, you just switch to x and y and solve for y. But basically if you've got AB, then you just switch BA, and that's a new point on your inverse function. Okay, so let's look which of the examples in 1 through 4 is an inverse function. So we're going to come back here. We're going to look at these functions, and we're going to say, are these inverse functions? Well, this is a line again, and so the line passes the horizontal line test, you know, because this, let's see, this is a line with a negative slope, correct? Okay, so we have a horizontal line test. Well, yeah, I mean, there's only one point ever, so that it does have an inverse. Okay, what about this one? Well, this wasn't a function to begin with. That doesn't mean that it can't have an inverse, but in this case, it fails miserably at the horizontal line test. So this one cannot have an inverse. Again, this one fails the horizontal line test, so it does not have an inverse. But looky here at this one. This one actually does have an inverse because it passes the horizontal line test, which makes sense. It's a parabola on its side. So, you know, if you switch the x and y, it's going to go up and down, and that makes it a function. So, let's see. So 1, yes. 2 was no, 3 is no, and 4 is yes. Ooh, my writing's beautiful tonight. All right. Find the inverse of this function. Okay, so again, we switch x and y. So we say x equals 2y cubed minus 1. Then we get y all by itself. So we have 2y cubed equals x plus 1. Divided by 2. Y cubed equals x plus 1 squared. And then we need to take the cube root of both sides. So the inverse of this function is f inverse of x equals cube root of x plus 1 over 2. All right, I'm going to stop there for now and make another video on piecewise and the other ones so this one doesn't get horribly long.